This video is all about using trigonometry in 3D. Now, before you start this, you've got to be okay with normal trigonometry. So sine, opposite over hypotenuse, cos, adjacent over hypotenuse, and tan, opposite over adjacent. So you're going to know your SOHCAHTOA. Now I'm going to jump straight into, well, doing it basically. So here we go. We got a cuboid. And it says here, calculate angle DFH. Now, let's signal that angle. So DFH, always a middle letter. So you know the middle letter is the actual angle you're looking for. So D is there, F is there, H is there. So if you draw this, I'm going to get a ruler. So I've got that and that there. So I've got DFH. So I know this is the angle I'm looking for. And what I normally do to start a question like this is I actually take the triangle out that I'm working with. So here we go. I'm taking this triangle out, what it would look like. So I've got that, and that is the angle I want. That is my X. Now, that is our D, that is our F, that is our H. So I've taken it out. Now, is there any information I already know about this triangle that I could put on there? So this length there, we know that because that is the same as that there. So I could already say 5 centimeters. Now, to find this angle, I now need to calculate either that side there or that side there. I know it's a right angled triangle. And what I'm going to do is, based on this diagram, I'm going to find out this length here, that length there, because I know that length is 5 centimeters, as this is the same as this there. So if I take that triangle out there, so I know, so this other triangle here, I know that is 12, that is 5, and it is Pythagoras' theorem here to find it. So 5 squared add 12 squared equals 25 add 144, which is 169. So this longest side here, we're going to find that now. So square root 169, which is 13. Okay. So we know that longest side of this triangle is 13, which is that length there, which is that length there. So that is 13. Okay, so we took that triangle out. We found that side that we didn't know by taking out a different triangle, and we've got it there. So we've got 5 and we've got 13, and we've got an angle. Now I'm going to put this, I'm actually going to draw this triangle again underneath just so we can now work with it. So we've got our D, our H there. We go across here to our F. Okay. This is the angle we want. 5 centimeters is that, and this is 13 centimeters. Now, let's check what we know. So we've got opposite, adjacent, hypotenuse. So we've labelled our triangle. Now we can solve it properly, find out what that angle X is. So we don't need hypotenuse. We've got opposite and adjacent, which is tan TOA. So tan X equals 5 over 13. So because we're doing that, we need to do tan minus 1. 5 over 13 is our X. So that gives us X as, we'll put it in the calculator. So shift tan, because that's what we're working with. 5 over 13. And we get a result of 21.04 degrees to 1 decimal or 2 decimal places. All right. Okay, I've got second example. So this time it's like a wedge. Okay, so using that in 3D, now we have to find angle BDE. So BDE. So just signaling where that angle is, so you know, BDE. Okay, and it's that one there. So once again, I'm going to take that triangle out to work with it. So put it here. So that's E up there, that's B down there. Go across, and that is our angle D. And at this moment in time, I actually don't know anything about this. I don't know that length, I don't know that length, I don't know that length. I need at least 2 of those to start working with it. I do know that's a right angle, yeah. So what we can start with is having a look here. That's here, we can make a right angle and use Pythagoras. So if we go like this, we know BAD, so that's 10, 10. We could use that for Pythagoras to find out this length here, BD, which relates to that there. So 10 squared add 10 squared is 100, add 100, so we get 200, and then root 200 gives us, so root 200 gives us 14.14. So we can now add this information into our original diagram, 14.14 centimeters, because we didn't know that before. Okay, now having a look again, we want to find out something else. So we can find out this height there using this triangle, because we've got an angle there, a 30-degree angle. So if we take this triangle out, so let's put this triangle here. I'll move my big hand in a second. So we've got E, B and A, that's 10 and this is 30. Okay, so we've got that there. Now, if we label our triangle with what information we do have, so we've got opposite, hypotenuse and adjacent, and you really want to find the opposite there. So you want opposite, so that's tan, TOA. So we've got tan 30 equals opposite over 10. So that means it's 10 times tan 30 to get the opposite there. So we put this in the calculator. 10 times tan 30, and that gives us 5.77. So that equals 5.77, and that is our length there, BE, which is our length there, which is also the length here, 5.77. Now, on this triangle that we started with, we'll come back to it quickly. We want to find X. We know that here, this side here is the opposite. We know this is the adjacent hypotenuse, but we don't need it, so it's a tan again. So we know tan X equals opposite 5.77 over 14.14. So it's tan minus 1 and then a 5.77 over 14.14 is X. So we put that in the calculator, shift tan 5.77, 14.14, close the bracket just in case, and we should get an answer for that of X equals 22 rounding it to 2 decimal places gives me 20 degrees. Now, there's actually a way you can do this with keeping the accuracy the whole way through, because I have rounded it And if you do keep the accuracy the whole way through, you get an answer of x as 22.21. So just slightly different there. But that will be your final answer to this question here of finding that angle there. And using Pythagoras, not Pythagoras, trigonometry and Pythagoras in 3D.